In single period planning, you make one decision and that's it. Very often in single period planning, the means of weighing the options of that one decision is expected value. We can see that here in this particular scenario. Let's look. The Regional Disaster Relief Service Incident Manager just activated the messaging alert system for a loadout. Okay, so we are working on an incident. One particular supply for loadout is not stocked, bottled water. RDRS has a partnership with a local bottling company, that's nice, which provides bottled water at, okay, this is a bit of data, I'm sure we're going to use it for something, $72 per pallet. If a pallet is not used, RDRS returns for a refund, returns it for a refund, less a $30 restocking fee. Okay, each pallet contains 60 cases of bottled water, and the shelter site normally consumes 2 pallets before other supplies are found. Oh, okay, wait a minute. So a little bit of backstory. I know that that's going to be important, but it doesn't really have anything to do with the price of the supply. RDRS sets up temporary shelter sites, disaster relief. What this is saying is that normally the site will require 2 pallets of bottled water. Okay, so 2 pallets of bottled water should leave in the loadout. It should leave with the initial wave of supplies, normally. Now, however, 25% of shelter setups use only half that. Okay, so 2 pallets normally. Sometimes this half that is basically 1 pallet. Rarely, oh wait a minute, there's other things that could happen. 3 pallets are consumed before RDS establishes another supply. All right, if RDS does not bring enough, it shops locally for bottled water. Makes sense. RDRS estimates that a pallet's worth of bottled water secured locally costs an average of $800. Now compare that to the 72. The incident manager estimates the likelihood of 3 pallets being needed is only about 5%. The incident manager must send a truck to the bottling company to pick up the bottled water. Remember, they are in the middle of a loadout. They're going to go set up a shelter site. This is our one and only question. This is our single period planning problem. That truck that just went out to the bottling company, how many pallets? How many pallets of water should it pick up? How many pallets of water should leave with the loadout? Now, with a decision, any decision, this is just one decision. The first thing that sometimes helps to clarify in one's mind is what are the options, because a decision is a set of options. We have one decision here that I outlined in yellow. How many pallets should the truck pick up? What actually are the potential options? Well, you could hear it in here. It's certainly a number of pallets. The only rational choices, it sounds like, have to do with this business here about how much might be consumed. You could, for instance, pick up 1 pallet, 2 pallets, or 3 pallets. Actually, technically, in terms of options, the truck could pick up 4 pallets or 1,000 pallets. None of that, though, makes any sense. I mean, the real gist of the decision is, okay, fine, should it pick up 1, 2, or 3 pallets? Because those, wait a minute, those are the possible futures that might happen. Now, at any rate, how are we going to decide? Should it pick up 1, 2, or 3? We have to assess each one of these options. Essentially, there's 3 rational options. Each one has a certain value. You say, okay, fine. What's that value? Well, notice that if you look at the currency signs in the problem, the only thing that's being discussed here is cost. That seems to be the major concern. Oh, okay. So each of the 3 options, should we pick up 1 pallet, should we pick up 2, or should we pick up 3? The thing we're really concerned about, and especially in the long run, is cost, right? Which would be the most effective in terms of cost. All right. Then what we need to do is assess each one of the options separately concerning its cost. Now, its cost is going to be kind of a little bit of a fuzzy issue because there's a bunch of different costs floating around here, and some of them are dependent on what actually happens after we make the decision. They take the stuff to the site and they actually start using the supplies. Now, wait, why don't we just start working on one of the options? There is a blank table, in essence here, that's meant as a worksheet for just one of the options. Okay, so let's work on the first option. Should we, for instance, the truck that went to the bottling company, should it pick up one pallet? Now, there are several factors chasing around here. We need to keep them straight, so I am going to draw some highlighter lines to help me keep my numbers straight, that's all. Because, first off, what are the different issues? Well, if we take one pallet, if we bring one pallet, you can see that the first line in this table, it says pallets consumed. Oh, right, wait a minute, what was that other information in the problem? It had to do with not how much water we brought, but how much water was consumed. There was discussion of low, a discussion of particularly normal. It said, wait a minute, pallets consumed, normally 2. And then they said rarely it was more than that, and that's been labeled high here. Now wait a minute, rarely it was more than that. They were talking about 3 pallets. Oh, right, because they said sometimes it's half that. Right, there are our future states of nature. They might, at the site, need 1 pallet, need 2 pallets, or need 3 pallets. So first we note that. There's like these 3 different things that could happen. Okay, now next line, pallets arriving. Well, this one's easy. This whole table, I'm going to analyze this option of only bringing 1 pallet. That means in each case, only 1 pallet's going to arrive. All right, now pallets bought retail. Well, if 1 pallet, the option is to buy it at the bottling plant. And so, okay, wait a minute. Buying it retail means that we must have run out, and we must have had to like run to every available convenience store and buy more there. Now wait, there are 3 different things that could happen. In each case we're bringing 1 pallet, but in the case of low consumption at the site, 1 pallet is enough. That means that, I mean, I wouldn't have to buy anything. You can think of retail as being like the emergency supply. Okay, well, if we brought 1 pallet and they only needed 1 pallet, we wouldn't have to buy any retail. As opposed to, now wait a minute, the other 2 possible future states of nature. If we bring 1 pallet and they consume 2 pallets, which is, they said, kind of what they normally do, we're going to have to find another pallet somewhere else. We'll have to buy it retail. And then here, if they consume 3 pallets, we've only brought 1, we've got to scrounge 2 other ones at retail prices. Oh, okay. Now, pallets returned. We'd only return pallets to the bottling company if we brought more than was consumed. That is not the case here under low consumption, because we consumed everything that we brought, and here we ran out, so this is actually boring. It's all 0. We didn't have anything extra to bring back to the bottling company. Now, wait, cost. These are all just facts. Notice this is not a formula, it's just logic. These are all just facts about what would happen with this option under the 3 different possible futures. Now, what would the spending have been? Cost at the bottling company, consumed at the shelter site. What that means is that we're buying 1 pallet at the bottling company and we're consuming it in this scenario, so that's that $72. And then wait a minute, we said we're buying 1 pallet and it definitely gets consumed under normal conditions because it's only half of what we need, so that's still $72. And here, that 1 pallet we bought is definitely consumed at the site, so that's $72. Now that's the only one kind of cost. Another cost to the bottling company returned from the site. Well, we didn't return anything in this case. We, if anything, ran out. Oh, okay, yeah, that's 0, 0, and 0 spent because 0 was returned. So there's only one other cost that was discussed in that paragraph that we should note. Cost of retail shopping near shelter site. We'd only be doing this if in fact we were buying retail. In this particular future, we don't buy anything retail, so that is no money. But in this particular future, normal consumption, we do have to buy 1 retail prices. And we noticed that up in the paragraph it said that's going to cost basically the equivalent of $800 a pallet by the time you find that much bottled water. And then wait, it gets worse. Under the high consumption scenario, we're actually short 2 pallets. We actually have to buy 2 pallets retail, so it's 2 times 800 for a total cost of retail shopping 1,600. All right, now what I just did is really just using logic, is I racked up for that one option, 1 pallet, the 3 different futures. I racked up all of the relevant outcomes and their costs. Why? Because we're concerned with cost, right? The next natural step is, let's just add up these costs. Let's tally them so that we have the cost of picking up 1 pallet under each of these futures. For instance, if we pick up 1 pallet and that's all that's consumed, that only cost us $72. But if we pick up 1 pallet and they need 2 at this site, that's going to cost us $872. And if we pick up 1 pallet and in fact it's one of those rare cases that they need 3, that's going to set us back a total of, I'm just adding these up, $1,672. You say, all right, fine. Now, here's the problem. We've only looked at one of the options. We're going to have to look at all 3 before we pick one. That's the whole point. So we need to pick one of these options. We need to pick one of these options based on a rational value for each one of the options. We're looking at one of the options right now, here. Our problem is we have 3 values for this single option. Right? We say, well, you know, its value is a cost of $72 if in fact consumption's low. Its value is $872 worth of cost if in fact consumption's normal. And then if, you know, like rare case consumption's high, its expected value then is $1,672. I don't need 3. I need 1 number. I need 1 number because then I'm going to compare it to that same number associated with the other 2 options. How do I combine these 3 numbers that refer to 3 different futures into 1 number that I can use right now? I'm going to use expected value. Now, how does expected value work? You have 3 different values. They refer to 3 different futures. You want to calculate 1 expected value to use right now. Whoops, there should be a U in value, expected value. How do you do that? Well, what you want to do is to take each one of the separate values and multiply it times the probability that that particular future might happen. You say, okay, wait a minute. The probability that that particular future might happen? Oh, that's some information we haven't used so far. Back up to the problem. That's nice. We got a little bit of space in here to work. There are these 3 futures. They concern consumption. You know, the consumption at the site might be low. It might be, they said, normal. You know, normally this happens, or it might be high. What's the probability of each case? In some cases, it was said, like it said right here, the incident manager estimates the likelihood, that's another word for probability, of 3 pallets, that's the high consumption, 5%. Oh, okay. That one it just said. Oh wait, and it said another percent here. It says, however, 25% of shelter setups only use half that amount, and it was referring to half of 2 pallets, or 1. That was the low consumption situation. Wait a minute. 25%, oh wait a minute, where did probabilities come from when people actually use them? In some cases like this, they say, well, you know, there's a 25% probability of something happening. They're basing it on the fact that in previous similar situations, that actually did happen 25% of the time. You counted up the number of times. That's what's being quoted here. We can interpret this statement, 25% of shelter setups, only using half of that one, as being a 25% probability it'll happen again. That's a very common way to estimate probabilities. So the only thing that we need is a probability now for normal. And you know, I don't see any percent signs. It didn't say anything about that. It didn't say anything about, we expect that normal will have a high probability. That's why they're calling it normal conditions. We know that it concerns 2 pallets. Wait a minute, and I know what that probability is. It's 70%. How do I know that? Because it's the only thing that's missing. And when you account for every future that could possibly happen, and you have the probability of each one of those futures, they have to add up to 100%. You've accounted for everything that could happen. We were only missing one of them, normal. It didn't actually directly quote the percent, but I just said 100% minus 25% minus 5% is 70% left over. Must be a 70% chance of these normal conditions where they just use 2 pallets. Oh, okay. All right, now wait, why were we doing that? Because we want to calculate the expected value of picking up 1 pallet at the bottling company. We need this information down here. Because we say, all right, there is a cost of $72 if you pick up 1 pallet and the consumption at the site is low. There is a 25% chance of that happening. I am stating it as a decimal place. 0.25, I want to say 0.25 times 72 plus, wait a minute, there's a cost of 872 if in fact the consumption is normal, and there is a, 70% chance of that. Let me be consistent, 0.7. 0.7 times this amount plus 0.05 is 5% times 1,672. This is what I want to enter carefully into my calculator. 0.25 times 72 plus 0.7 times 872 plus 0.05 times 1,672. This is how expected value works. Grab each one of the values and multiply it by the probability of that particular outcome happening. Okay, roll that all up. I did. And I got 712. And what we want to do at this point is put a big box around that so that we don't lose track of that number. We're going to need it later. Okay, but we have our first, it's not going to answer the question yet, we have our first conclusion, and that is that the expected value of picking up 1 pallet at the bottling company is $712. You can see that the way that expected value works is there's 3 things that could happen. There's the probability of each of the 3 things that could happen. You're grabbing a chunk of each one of the things that could happen. How big a chunk? It's proportional to the likelihood that that would actually happen. Anyway, maybe that's not very helpful. Grab each one of the values, multiply by the probability that that value was going to happen, add them all up. That is expected value. All right, now we still have to decide how many pallets to pick up, which means that we have to assess the other 2 options. Which is why if you have the note frame, there's another page with the same table frames. Because now it's time to look at the option of picking up 2 pallets at the bottling company. All right, now maybe I better just so that I don't go off the rails, make myself some lines. This is essentially, if you think of it as an invoice, it's all the same line items. Because pallets consumed under the 3 future states of nature, that doesn't change. Low is 1, normal is 2, 3 is high. Pallets arriving. Now remember, this is a different scenario in which we elected to pick up 2 pallets at the bottling company, which means 2 pallets arrive in each case. Pallets bought retail. Now we just have to do the logic, the comparison. If you bring 2 pallets, they only use 1 pallet, you do not need to go run to the store and get any more. You won't buy any retail. If you bring 2 pallets, they consume 2 pallets. That was actually perfect. It's only if you bring 2 pallets and it turns out they want to use 3 pallets, you're going to have to find another pallet retail, so that's 1. Pallets returned. Okay, if you bring 2 pallets and they only consume 1 pallet, that means you're bringing 1 pallet back with you on the truck and returning it to the bottling company. If you bring 2 and they use 2, you are not bringing anything back. That was perfect. And if you bring 2 and they use 3, you're definitely not bringing anything back because you actually ran short. All right, now that's just the logic. What about the costs? First off, costs of that bottling company consumed at shelter site. If you bring 2 and use 1, that cost, the cost of what you used at the site, is that $72. It's $72 a pallet. If you bring 2 and they use 2, then okay, your cost of what was used from the bottling company is 72 times 2, or 144. If you bring 2 and they need 3, you definitely used the 2 that you brought from the bottling company, so that's 144 again. That's what you paid for those 2 that were used. Now, cost bottling company returned from the site. If you bring 2 and they only use 1, you return 1, right? That had a cost. They said they would give you your money back, but there was a $30 restocking fee, so that's basically the cost of that one. Okay, you brought 2. This one cost $72 because you used it, and the other one cost $30. Now, in the case of the other 2 future states of nature, you don't have any that you're returning, so you don't pay anything in that. And then cost of retail shopping, we don't do any retail shopping for low consumption. We don't do any retail shopping for normal consumption. It's only high consumption here that we had to run out and find another pallet, which means that set us back $800. Now, total cost, we just add these up. Okay, this is going to add up to $102 in costs in the case of low consumption, and then $144 in the case of normal consumption, and then what is this, $944? $944 in the case of high consumption. All right, there is, for the option of picking up 2 pallets, the 3 different costs. We want to combine them into one expected value. Let's see if I can spell value correctly this time. Expected value. In which I say, all right, 102 is what it costs under low consumption, and 0.25 is the probability of low consumption, plus 144 is what it costs with normal consumption, times 0.7 is the chance of that actually happening, plus 944 is the cost for high consumption, but there's only a 0.05 chance of that happening, so I'm only going to grab 5% of that big number. I'm going to do the multiplication first, add them up. I get 100, that's a 1, $73.50. $173.50. And I'm drawing a big box around it because all of that work was to find that one number, and I want to be able to retrieve that one number later. That's the expected value, $173.50. That's the expected value of picking up 2 pallets, the option of picking up 2 pallets. Now, we have to do this for all of them, so we're up to 3 pallets. 3 pallets. Should the truck right now just go ahead and pick up 3 pallets? Pallets consumed, that doesn't change. 1, 2, 3. Pallets arriving now means 3 goes to the shelter site. Pallets bought at retail. Okay, if you bring 3 and only use 1, you definitely don't need to buy anything. And if you bring 3 and only use 2, you don't need to buy anything. And if you bring 3 and you only use, okay, you don't buy anything at retail under this particular scenario. Pallets returned. Okay, I think we're going to be doing a lot of returns here, because if you bring 3 and only use 1, you return 2 pallets. If you bring 3 and only use 2, you return 1 pallet. It's only here that you don't return anything. Now, costs. Cost of pallets bought at the bottling company, that were consumed at the shelter site. In this scenario, we only consume a pallet. It was definitely bought at the bottling company, so that's $72. In this scenario, all the pallets we consumed were bought from the bottling company, so the cost of that consumption is $144. And in this scenario here, all the pallets we consume were bought at the bottling company. That's 3 pallets, so 3 times 72 is total spending of $216 to purchase that. Now, that's what was consumed. What about the ones that came back? Cost, bottling company, returned from the site. Okay, under the low consumption scenario, we bring back 2 pallets. We are charged the stocking fee twice, so we basically spend $60, 2 times 30. In the normal consumption scenario, we bring back 1 pallet That's the $30 restocking fee, and it's only in the high consumption scenario that we're not returning anything, which means you don't pay anything in that category. Then, finally, cost retail shopping near shelter site. Oh, well, if you bring 3 pallets, you're not going to be doing any retail shopping. So that's nice. Nothing, nothing, nothing. Okay, let's add these up. Let's tally this. That means that this option, the low consumption scenario, sets us back a total of $132. The normal consumption scenario sets us back $174. And the high consumption scenario sets us back $216. I want to calculate the expected value of this option. So I say 0.25 times 132, that's low, plus 0.7 times 174, there's normal, plus 0.05 times 216, there's high consumption. I did that and I got on my calculator $165.60. And I put a box around it so I don't lose track of that one number after all those calculations. Because you say, are we done yet? Almost. So what was it that we were trying to do? We were trying to answer one question. It was a single period planning inventory problem. Let's go all the way back to the beginning, right? There, I drew a yellow box around it. We're trying to answer this question. How many pallets should the truck pick up? We now have everything we need to make that decision, because the truck might pick up 1 pallet. We now know the expected value of that option is $712. It might pick up 2 pallets. The expected value of that is the $173.5, or 3 pallets. We just got finished with that number. That's the 165.6. We need to pick one of these. That's the recommendation. Oh, right. So which one wins? Okay, now this is the expected value of each one of the options. In order to make a decision based on that, it pays to check wait a minute, what does this refer to? This refers to cost. Oh, that means I'm going to like lower numbers. Lower numbers are better. Which would be the best? The one with the lowest expected cost. Oh, so that's 3 pallets. In any given kind of expected value problem, you might be calculating, for instance, the expected value of profit, and then you would like higher numbers, right? But in this case, what we're looking for is lower numbers, because this is pure cost. Oh, so the answer to that one question after all these computations is, you know, that truck that went to the bottling company, it needs to pick up 3 pallets. RDRS should pick up and send to the shelter site 3 pallets every time it does a loadout. Now, the ironic thing is if you look at the original information, that's the answer, 3 pallets. It has the nicest expected value. If you look at the original information, you go, you know, isn't that kind of funny? Because the only time that you would ever use 3 pallets is 5% of the time. 5% of the time you would actually need 3 pallets of bottled water at the site. And we're saying that the answer to this question after this analysis is that they should always bring 3 pallets of water. And the answer is, yeah, even though they have to pay that $30 every time they bring back water that they don't use, and most of the time they will be bringing back water that they don't use. The answer is yes. The reason that this outcome came out the way that it did, and this is what expected value is helpful in, is that while they have to pay for the water that they bring back, and they'll be bringing back water most of the time, that is nothing apparently compared to the shopping at retail. Expected value gives us a means of taking these 2 different costs concerning 2 different things that could happen, right? Having to bring water back or having to go buy it at a convenience store, and gives us a rational way to mix them together to basically then, in a balanced way, compare them. Okay, the comparison says whatever you do, pick up the water now and put it on the truck to the shelter site.